Hello and welcome back. This is Conversation in Artificial Intelligence. This is Paolo, your host. It is an honor to have you here today. And today we're going to talk about a topic that I find extremely interesting. And basically we're going to expand from the biases of artificial intelligence into how we counter those biases and how we make artificial intelligence easy to adopt for companies. So with us today, we have Krishna Gade from Fiddler.ai. Hello, Krishna. How are you today?
Hi, I'm well. Thanks, Paolo, for the opportunity to speak about Fiddler and what we are doing.
So, Krishna, before we go into talking this very interesting topic, you have recently started this company by the name of Fiddler.ai. What was that made you starting the company, and how did you actually take steps towards making this becoming a reality?
Yeah, so we started Fiddler Labs 6 months ago with the key insight that we had when we were speaking to a lot of companies introducing machine learning, and we sort of walked them through like what were some of the problems that they were facing. And one of the things that came through was a lot of the companies that are introducing machine learning in deploying machine learning models were facing with this issue of like sort of black box AI, right? So, and this is coincidentally, this is something that I worked on at Facebook as well, where I was an engineering lead on the newsfeed team, where part of my team worked on actually explaining how a newsfeed works to the rest of the company, and and this sort of like came through a realization that hey, like I think there is a need for a general purpose platform that any company that's introducing machine learning in production or sort of like considering to do that would need our tools to kind of be able to debug and diagnose and sort of like models that they're putting into production so that they can be more aware of like what their models are doing, like whether that's like are the models being biased, how are the models performing, and so on and so forth.
What do you make of the balance between AI biases and human biases? Where do you think we are headed at this point?
Yeah, this is a great question, and I think our take is that hey, like bias in humans has existed over centuries, right? And that's something that it's sort of like we've been aware of for a long time, and the same bias is reflected in the data that is collected to train these models. So as a society, so we may have not we may have not accomplished equity across all genders, demographics perfectly. So as a result, whatever data that you collect to train your models will have a certain bias against certain demographic or certain gender groups, and so as a result, this bias will creep into models, and this is a problem, and this is a problem for companies, because what happens is when you actually train these models and you're automating decisions, what can happen is this bias can be amplified at scale, right? And but the good news is that unlike human bias, machine bias can be detected, right? So that's kind of what we are building towards. Like tools like Fiddler will help companies to detect if like the machine learning models have bias in them, and so that they can address them. So you may have a situation where maybe a human made a decision in the past and you have no idea how to reason about it, how to correct it, or how to even call out the bias explicitly. Whereas today, if a machine were today make the decision using and eventually in the future with tools like Fiddler, companies will be able to detect it, potentially correct it, and sort of either post correct it or sort of like apply techniques in what kind of data that they need to supply to the models. So I think while bias is a concern, I think this is addressable.
Where do you think is the right point at which we should deploy an AI solution regardless of the bias? Like, what is the balance, the right point where you say, you know what, even if I have a bias risk here, solution is still better than what we have today?
Yeah, so that's a very good question. So I think if you kind of think about like the trade-offs that exist, right? So there is like performance that you want to achieve through machine learning, sort of accuracy, precision of machine learning models. There is this whole concept of keeping the model fair to all the people, and there's this whole essential ability to preserve the privacy of the people, right? So all of these three concepts are kind of like have trade-offs with each other. So for example, if you want to keep your data completely private, then you cannot actually apply any correct kind of post-correction techniques to keep like the model decisions fair for everybody, right? Because unless I know your your race or gender or the school that you went or the zip code that you're in, I cannot like kind of make the model performance, or at least at an aggregate level, I cannot make the model performance fair for the demographic that you may belong to. So they're all there are the trade-offs that exist, right? So it's up to the practitioner to decide on to sort of where they would want to lean on with respect to performance and bias. So for example, maybe in the case of like sort of a code decisions, right? Like, so where human life is at cost, maybe it's important to actually to be more precise, right? But then how do you actually be more precise and not be biased? And that's a big challenge when it comes to maybe healthcare, or where the outcome of the decision, it's very important for the model to be precise, and that's where you need to figure out that. It's up to the practitioners to figure out where they want to sort of keep that dial in, and how much they want to sort of optimize for like performance or fairness, and then how over privacy, right? So this is a complex problem, and I think there's no sort of perfect answer for it, and I think what they need right now, what we are building here, is kind of providing visibility into these issues so that the practitioner can make those decisions for each given situation.
So you have, expanding on this, you have worked at Facebook for a number of years, and you were working in the newsfeed organization. Now, one of the indirect problems of AI bias and being able to detect these biases is that there is less confidence in the organization to basically invest or develop or release new products, because you never know what could happen. Could you talk about, if you have any anecdotal story or any, what is your viewpoint on this particular thing? How is this uncertainty, insecurity blocking, if you like, innovation within companies?
So machine learning is going to come in whether you like it or not, right? So I think it's very important for businesses to adopt machine learning or AI to advance and to kind of give the best possible user experience, personalize and improve operational efficiency. Otherwise, I think they're going to be, in the long run, they're going to be sort of like outgunned by other new businesses that would adopt AI. So the question is, you need to adopt AI, but how do you do it in a way such that you actually are aware of how your AI systems and AI products are working? So what at Facebook and the newsfeed team, and when you come to newsfeed, the content that you see is highly personalized to you. Like, it's basically content coming from your friends, the pages that you follow, recommendations, and everything is personalized to you, your activity on the site, or your engagement, your likelihood of engagement towards the content. But what happens is, when we didn't have explainability for newsfeed, we did not know why someone was seeing any particular story, and this was very important for us, like as a sort of a diagnostics tool, right? As a debugging tool, like wherein, why am I seeing this story, right? Like even from like executive to an engineer at Facebook was always asking this question. And this also has twofold. One is it also helps us to diagnose and debug when a publisher complains to us, say, hey, like why are we losing distribution of our posts and whatnot? So we would go back and see, because there are lots of sort of ranking experiments being conducted at Facebook. There are lots of new machine learning models being introduced, and these machine learning models have become more and more complicated over a period of time. And so what happens is, when you are just presented with this ensemble of black box, the question of like, what is going on, how is the system working, becomes important.
So what is, in your opinion, or what is the business model that Fiddler.ai is going to pursue?
So one of the things that we are trying to build here is to help companies build AI right? So far, there have been a lot of startups and companies that provided vendor solutions to companies. Hey, like, here's a way to build AI fast, right? Like, here's a way for your data scientists or ML engineers or anyone in the company to kind of build models and deploy them really fast, right? Whereas where we are coming from, our value prop is, hey, we will help you build and deploy those models in the right way, right? And so in a trustworthy way, so that you're actually ensuring that your end users still sort of continue to trust you, and you retain them, and you can address like some of the compliance issues, whether that's GDPR, and you can get insights into how your models are working, what they're working. So our product is a SaaS product. So we're available on AWS, and so businesses can use us like any other SaaS platform that they're any other Amazon service, just like any other Amazon service. And we're also integrating with other providers as well. So wherein, let's say if you're building and deploying models with another vendor, you could also use us in a pluggable way. So you could actually use us to sort of like make sure that the models you're deploying are compliant, are risk-free, they're bias-free, and so you can actually see how the models are working before they deploy, and then you can continuously monitor those models and understand how the model performance is doing, what it is, and how, and it can actually address any customer complaints, and sort of be aware of how the models are performing within your company.
So what it is that Fiddler does, will analyze the models inside other companies, will analyze the model in production.
The way you can consume the product is we have simple kind of SDKs and command line tools to ingest your data and models into our system. We also have services that can run within the VPC of a customer if the customer really cares about data security and model security. Either way, they can actually upload their models and data into the service, whether that's on our managed service or the service deployed to their sort of VPC. And once they do it, then they're presented with a really nice, visually rich dashboard where they can go and inspect various different models, understand how the models are performing against the different data sets, get insights into explainability, fairness, get insights into the runtime performance of the models, monitor the models, and actually debug the models at runtime. And so all of this is kind of consumable through our rich dashboards.
Who do you think is the ultimate user of this service? Is it more the engineer, or is it more of a product manager, or is it more of a manager?
I think we have our target users are kind of all of the above, right? So the data scientists can use us while they're developing the models to inspect how the model is performing, right? And once they deploy it, they can let the operations teams use our dashboards to monitor the models and understand how they're performing. They can actually understand, like they can also work with the data scientists if any customer complains about, hey, like why did this happen? And so the operations person can work with the data scientist to debug why the model predicted what it predicted, and do they need to correct any mistakes or retrain a model or whatnot. And then similarly, the sort of the business owners, the product managers can actually sort of be aware of all the models that are running within the system, the comprehensive analytics around models, and sort of like get reports around explanations and analytics on model performance.
So now, for many years, people have been saying these machine learning algorithms are like black box, and this type of this type of thinking also became more relevant with the inception of deep learning and deep reinforcement learning for a variety of technical reasons. So what has changed in the last few years that made a service like Fiddler possible?
I think there has been a lot of research that's going on within explainability of machine learning, right? Especially in the last 2-3 years. There's a lot of new algorithms being published around explaining models in a black box manner, and some of these algorithms actually work pretty well, right? And some of these algorithms were what we implemented in Facebook as well, and at scale for many different kinds of model architectures, right? And so we are piggybacking on that research. We're basically kind of productizing some of those algorithms. So one of the problems with some of the algorithms is like they may need to be like made more scalable and to operate on larger data sets, to operate on like more complex models. And as part of productizing explainability, we are taking some of those ideas and improving upon them, right? And similarly, there's a lot of work that's happening within white box explainability as well. So when I say white box explainability, it's actually going deep into the model itself, understanding various stages of the model architecture, how what do they get, what's happening when an input passes through the model. So for example, let's say if you have a neural net, it might be like, okay, what neurons are actually coming together to actually make the sort of the prediction, right? And so what we are building is also sort of what white box explainability, wherein we are baking the explainability right into the sort of the machine learning library, so that you, when you as a customer, when you run the model input through the system, we can actually help you visualize the entire network of like what's going on at various stages of the neural network, and can do side by side comparisons with different inputs, so you can actually glean insights into like why is the model performing this way.
You know, one of the interests here on this channel is how we leverage machine learning to build products, and it looks like you're basically leveraging some of the new algorithms and research to build a software as a service product.
Yep.
Could you dwell a little bit more on what are the challenges of productization? How do you go from a research model to a real product?
As you can see, when it comes to machine learning, it's the kind of the libraries and toolings is very fragmented, right? So data, there's no standardization yet. I think it will eventually get standardized, but today, as a data scientist could be using any one of these libraries, whether that's scikit-learn or PyTorch or TensorFlow or Caffe or even R, to build these models, right? And they may also be using some proprietary stacks like SAS and whatnot to kind of like create these machine learning models. And a system that explains it should be able to work across these different model formats and different modeling libraries. And to make things more complicated, there are a wide variety of new machine learning algorithms that are coming up, whether that's sort of multiple different kinds of deep neural nets and decision trees, random forests, logistic regression, whatnot, right? And so the explainability system should be able to work across these different kinds of model architectures themselves. And then you have this problem where you have lots of the data would come in with various different ways, right? So you may have data that comes through like in a structured way, like tabular data, right? And you may have data that comes in an unstructured manner, like image data, text data, and more, and speech data. So being able to sort of having explainability work across different data types also is very challenging. So what we are trying to provide is to kind of pick a few data types, pick a few modeling libraries, and pick a few sort of modeling algorithms, make sure that our explainability works on those things, and sort of and essentially go from there, right? So it's definitely a long way out to be able to have build a fully functional explainable system across everything.
How do you make sure that this portion that you're carving out is the right product market fit?
One of the things, as part of, we've done numerous case studies with lots of customers, both like in technology sector, finance, healthcare, even companies, the big companies that have not adopted AI. I think one of the things that you see is if companies that have deployed machine learning are worried about things like compliance, things like not being able to get visibility into AI, not like kind of being able to deal with black box models, worried about poor branding and PR, potential bad PR issues in the future, right? So and the companies that are very early into the stage of AI, they are worried about like, okay, should I actually introduce machine learning? Would it actually complicate things for me in other ways? So on both sides, they have different concerns, right? And so what we are providing them, hey, so if you use the Fiddler platform, we can address those business risks for you, and you can kind of adopt machine learning in a way so you can actually get more visibility into what's going on, and so you can actually be on top of those things. So what we are helping them is, hey, we are here to help take care of that business risk for you. In some ways, if you think about it, today machine learning is like machine learning platforms are like operating systems without security, right? And so we are becoming the security layer for AI. So it's kind of, we are basically providing this, hey, when you use Fiddler, you don't have to worry about like this business risk around explainability or black box models or compliance.
Help us visualizing an example of a business application where Fiddler can help.
So for example, today, if a customer goes to a bank and asks for like a credit line increase, let's say they have a credit card worth $10,000 and they want to request for a larger credit line, maybe to $20,000, right? And so these kind of requests are fully automated in banks, and so there's no human in the loop. So this request goes to a system that probably queries a credit lending model that someone has created, a data scientist may have created in the bank, and based on the score for the model, the decision whether to actually approve the request or not is made, right? And so the model, it takes in a whole bunch of features about this customer, where his this person's age or salary, FICO score, like asset total sort of amount and savings and whatever, like the whole bunch of attributes that the model has been trained with, and makes the decision, right? Now from the, if the end user, let's say if the end user doesn't get what he like, I mean, there can be many things that can go wrong, right? So in one case, like they may sort of like want to sue the bank, or they may want to sort of like pursue a certain sort of situation where they may ask for like, hey, why is this not happening, right? And on the bank's perspective, they have no visibility into what happened. Like we had like 1,000 requests last week, what did our system do, right? And so what, and when an auditor comes and visits a bank, or a regulator comes and visits a bank, they have sort of they don't have a lot of tools to show what their systems, what they're doing, why they're doing. So using a system like Fiddler, the banks like risk management teams can actually get sort of an explanation report of what has happened in the last week, what were the people who came through the system, and what did we approve, what did we not approve, why did we approve, why did we not approve, is there an opportunity, or is there any bias in any of these situations, do we need to go back and improve any of those models? So that's kind of where our system would be valuable.
Do you think it's going to be a large use case in the future? Do you think it's going to be one of the use cases?
I mean, as I said, the example is right now, ML platforms are like operating systems without security, right? And so the explainability layer is what security is to the operating system, and especially from the business angle. So it's going to be very important. And explainability will help many things, right? One is to help your within your company democratize the insights around machine learning, like helps your employees ask what if questions. This was a big use case at Facebook, right? So any technology company can use our platform so that within their company, any user can ask like, hey, what's going on, right? This will also help as like a kind of a customer support issue, where your operations teams dealing with customer supports, whether there's account executives managing large accounts, when they need to sort of address the customer pain, they can go back to these tools and understand what's going on. It's kind of like kind of like a customer support or operational tool to kind of make sure that their machine learning products are doing what they're doing. And this can also help like auditors, so that they can basically like review these models periodically, understand these model performance, and make sure that there are no sort of bad issues like bias or anything creeping into these models, right? And then finally, this will help the practitioner himself or herself, like where when they're building these models and deploying them, they can continuously be aware of like what's going on within the machine learning system.
So if somebody is coming out of college today, or is in the first years of his career, okay, so how does he become a machine learning engineer, and what are the top 2 or 3 career advices that you would give to them?
Anyone coming out of school from anywhere has a huge amount of resources, whether that's courses like Fast.ai, Coursera, or any number of YouTube videos, and multiple Slack channels and Facebook groups that you can join to kind of interact with other people working on machine learning and data science, and kind of like keep yourself updated, and also like train yourself as a data scientist or machine learning engineer. Grad school degree will help to some extent, because it'll kind of further validates and kind of gives a little bit of structure to this thing, so that when you are kind of working, when you're studying in school, taking like courses like linear algebra and algorithms and sort of machine learning courses, and when you're actually pursuing a program like a master's in data science program, there are lots of grad schools that are offering these things. There are also schools like Lambda School that offer this as well, right? So having a curriculum will also be helpful in addition to your own personal training. I think the great data scientists are are people who actually are curious about solving a business problem.
So for our audience today, we covered these very interesting topics of creating algorithms that basically spy the other algorithms and can explain how they work. And this is very interesting for a variety of reasons, from helping data scientists to make the algorithm better, eliminating biases, helping companies to accept new machine learning products, but also helping regulatory bodies to have a tool to do a checkup on what's going on. And this is going to be ever and ever more important as machine learning gets applied to a lot of areas in the human societies, and some of which are pretty delicate, including policing, healthcare, justice, and also all the finance and insurance and so on. So if you have questions about this particular video, please comment on the social media where you find this video. If you have requests for similar or slightly different content, please reach out to me. And for the time being, Krishna, thank you so much. It was a great pleasure having you here.
Thank you, Paolo. Thanks for the opportunity. It was great talking about explainability and the future of explainable AI with you.